This next video, 1.2, is just a continuation of 1.1. So we're going to be still looking at reaction rates, but this time we're going to use reaction rates using balanced equations. So we're going to be looking at stoichiometry. So for example, they might give you that ethane is consumed at a rate of 0.066 moles per second. So ethane is the C2H6. So the C2H6 is being consumed at a rate of 0.066 moles per second, and they want you to calculate the rate of consumption of oxygen also in moles per second. So we are going to be converting from ethane to oxygen within a balanced equation. So the rule is once you're in moles, you can do anything you want. So you can move within your equation using mole to mole ratios. So we're going to start with 0.066 moles of ethane is consumed per second. And we want to convert this to the consumption of oxygen in also moles per second. So the only thing we really have to do is convert from moles of ethane into moles of oxygen. So we know that 2 moles of ethane will consume 7 moles of oxygen. And then you plug that into your calculator. You get 0.066 times 7 divided by 2, and you're left with, to 2 sig figs, 0.23 moles of oxygen per second. Right? All right, let's make it a little bit harder. So in this next reaction, they're going to tell you that 67.5 grams of aluminum is consumed per second. So this is 67.5 grams per second of aluminum is consumed. And we want to find the rate of consumption of bromide, okay, in also grams per second. So how are we going to do that? Well, let's start that we know that our rate of consumption of aluminum is 67.5 grams per second. We want to be able to convert this to the consumption of bromide also in grams per second. But we can't go straight from aluminum to bromide in grams. We have to go through moles. So the first thing we're going to do is convert grams of aluminum to moles of aluminum. So we know that 1 mole of aluminum weighs how much? Well, let's look on our information booklet. We find aluminum, which is element number 13, and its molar mass is 26.98 grams per mole. Okay, so now we're in moles per second of aluminum, which means we can convert to moles per second of bromide. So we're going to say that in this reaction, 2 moles of aluminum consumes 3 moles, or reacts with 3 moles of bromide. So now what am I in? Well, I'm in moles per second of bromide, right? So if you wanted to go through and look at your units, right, we went from grams of aluminum into moles of aluminum per second. Then we went from moles of aluminum per second into moles of bromide per second. And now we want to convert to grams per second of bromide. So we are going to use our molar mass to say that 1 mole of bromide weighs how much? Well, bromide is made of 2 bromines, right, because it's diatomic. Each bromine, where is it, weighs 79.91. So we're looking at atomic number 35. So 79.91. And so the molar mass of bromide, because it's diatomic, is 79.91 times 2, which gives you 159.82 grams. So then we plug all of this into our calculator. We get 67.5 divided by 26.98 times 3 divided by 2 times 159.82. And that leaves us, what do we want our answer in? 3 sig figs. So we get 599.769 ... So to round this to 3 sig figs, this 9 is going to get rounded up to a 10. This 9 is going to get rounded up to a 10. So we're going to end up with 600 grams of bromide per second, or grams per second of bromide, whatever you want to say. Awesome. So go and practice those stoichiometry questions.